Hello everybody, in this question we need to show that cos of a plus b plus cos of a minus b is 2 cos a cos b. That's the first bit, and hence we need to show that cos of p plus cos of q equals 2 cos p plus q over 2 cos of p minus q over 2. And then we need to solve that 0 less than equal to theta less than equal to pi over 2. The equation cos 5 theta plus cos 7 theta is 0, and give each solution in terms of pi. And we need to show that cos of 8x plus 2 cos 6x plus cos 4x is 4 cos 6x cos square x, and use calculus to find the exact value of 0 to pi over 3 cos 6x cos square x dx. So let's start with the part A, start proving the formula, which is quite straightforward. So for part A, we're showing that cos of A plus B plus cos of A minus B. So I can write here cos of A plus B plus cos of A minus B, and that is equal to expanded, so cos A cos B minus sin A sin B, and plus expand this cos A cos B and plus sin A sin B. So that's straightforward. Those cancels out. 2 cos A cos B, and that's the answer. So that's right hand side, so that's done. So let me so that's the part A done. So we have to move on to the B part. So the B part is saying, it's a pen color. So the B part is saying, hence show that cos P plus cos Q equals 2 cos P plus Q over 2 cos P minus Q over 2. So for that thing, say B, so what I can do is, I can put in, say, P is equal to A plus B and Q is equal to A minus B. So then if I add, then it will be P plus Q is 2A. So A is P plus Q over 2. And if I said P is, if I subtract, so I'm writing it again because otherwise I have to erase that, minus B, and if I subtract, no, sorry, it's A that goes off. So just 2B is P minus Q. So B is P minus Q over 2. So then I can write, so this is my left hand side, and this is the right hand side. Then I can say the left hand side is equal to cos P plus cos Q, and that is equal to cos of A plus B plus cos of A minus B, and that is equal to 2 cos of A cos of B. That's from the formula. So now we replace the value, replace A with P plus Q over 2 and B with P minus Q over 2. So that is equal to 2 cos of P plus Q over 2 times cos of P minus Q over 2. And that is right hand side. So that completes the second bit as well. So I need to put a ring around it. So that I know that this is done. And this is where I'm writing all over the screen. Don't want to mix things up. Yeah. So then the C bit is a solve thing. Okay. So cos 5 theta plus cos 7 theta. So let's see. Now 7 theta and 5 theta, isn't it? See, 7 plus 5 is 12, and 12 divided by 2 is 6. So we can say in terms of 6 theta. So I say cos of 5 theta plus cos of 7 theta is 0. So I can say therefore cos of 6 theta minus theta plus cos of 6 theta plus theta is 0. So I can now say that this is 2 cos of, or rather I can, bring the plus thing first. So therefore cos of 6 theta plus cos of 6 theta minus theta equals 0. So that is equal to, you can say 2 cos A cos B, so 2 cos 6 theta cos theta, so not equal to, we need to say therefore cos 6 theta cos theta is equal to 0. So if cos theta is 0, then you get theta is 90 degrees, that's pi over 2. So we can't say 270 or 3 pi over 2, we can't use that here, not in this case. So for the next one, it's a little bit, because we've got 6 theta, so we can say, or 2 cos 6 theta equals 0. So we get cos of 6 theta is 0, and we get 6 theta is equal to 0, means it is pi over 2, because then it is pi over 12, theta would be pi over 12, and theta must lie between 0 and pi over 2, not 6 theta, okay, that's a bit to note. So then I can also write it as equal to 3 pi over 2 and 5 pi over 2. Can't write any more, that will be over pi over 2 then. So therefore theta is equal to pi over 12, 3 pi over 12, and 5 pi over 12. So that's 15, 45, and 75 degrees. So we can't do the next one, this will be more than 90 degrees. Okay, so these are the values. So then these are the values of theta, and that's the answer. That completes the C bit. Now for the D part. So once again we'll use the so we'll say this is left hand side and right hand side. So for the part D, to go up, scroll up to read the questions. Cos of 8x, we say left hand side is equal to cos of 8x plus 2 cos 6x plus cos 4x. So this I can write as, I can write it in terms of 6x, because I can group this, and this thing will remain on its own. So if I write in terms of 6x, probably it would help. So I'm going to write things in terms of 6x. So I can write this as equal to cos of 6x plus 2x plus 2 cos of 6x plus cos of 6x minus 2x. So that is equal to 2 cos of 6x cos of 2x, and then plus 2 cos of 6x, isn't it? So cos 6x, 2 cos 6x, cos 2x, plus cos of 6x. So then what do we do? What do we do after that? So we've got cos 6x as a common, isn't it? So 2 cos 6x, I can say that is 2 cos of 6x times cos of 2x plus 1, can't I? Yes, I can do that. Now what is this cos of 2x plus 1? So you see cos 2x can be written as cos of x plus x. So once again going back to our formula, 2 cos A cos B, no, that's not the one, that's A. No, we can't use that, not really. Yes, we are using that, but in a little bit different way. So cos 2x is cos of x plus x. So we know the cos formula, we used it here. So not the question, we used it here and we expanded it here. Cos A plus B. So cos x plus x is cos x times cos x minus sin x times sin x. That's what it will be. So I was looking in the wrong place. So here, so then that is equal to cos x sin x minus, sorry, wrong thing. So cos x minus sin x, that is cos square x minus sin square x. So there is no sin square x in our right hand side, it's only cos. So we need to change it. So that is equal to cos square x minus 1 minus cos square x. So that is equal to cos square x minus 1 plus cos square x. That is 2 cos square x minus 1. I believe there's a formula like that. I didn't remember that, so I just did it. So then that is equal to 2 cos of 6x and then times 2 cos square x minus 1, and then don't close the bracket. This plus 1 is remaining, so plus 1. So then that is equal to 1 and 1 go, and it is 4 cos square x cos 6x, and that is right hand side. Yeah, 4 cos 6x cos square x, 4 cos, so I can say 4 cos 6x. So that completes this bit, the part D. So we are going to use this result in part E. Okay, so we will use this result. So So we will use this result in part E. This bit is the same. So we just need to add a 1 over 4 and a 4. And we can use that. So let's do that. Part E. So I have to go further down. So this is done. One bit done. The next bit done. So then I'm going to look at part E. So where's the question? Integrate 0 to pi over 3, 0 to pi over 3, cos 6x cos square x dx, 6x cos square x dx. So then I can write this is equal to 1 over 4 integrate 0 to pi over 3 times 4 6x cos square x dx. Right, so then I can do, instead of writing for 6x cos square x, I already know that it can be written as cos of 8x plus 2 cos 6x plus cos of 4x, which is the part D. And that makes this question much easier. So then what I can do is, I can just write that this is equal to 1 over 4 and then integral sign 0 to pi over 3, and then I put a bracket and then I write that is equal to cos 8x plus 2 cos 6x plus cos 8x plus 2 cos 6x plus cos 4x plus cos 4x. And then you see it can be integrated very easily because we know the integral of cos x is sin x. So then I can do, so I missed the 4 here, oh no, the 4 those. So that is equal to 1 over 4, then I'm going to write this, so cos 8x is so I get this as 1 over 8 sin 8x plus 2 divided by 6 sin 6x plus 1 over 4 sin 4x, and that's 0 to pi over 3. So then putting in the values, 1 over 4, 1 over 8 sine of 8 pi over 3 plus 1 over 3 sine of 6 pi over 3 and plus 1 over 4 sine of 4 pi over 3 and minus 0, because all of them are 0 when x is 0 and sine 0 is 0. So then I can write them. We have to find out what each of these are. Now we know sine pi over 3. Sine pi over 3 is root 3 over 2. However, the sign has to be positive, so it has to lie only in the first two quadrants. So if this is pi over 3, that is 60 degrees, pi over 3. So what's 8 pi over 3? So then we have, this is pi over 3 first quadrant, the second quadrant it's pi minus pi over 3, that is 3 pi minus pi, that is 2 pi over 3. Here in the third quadrant it would be pi plus pi over 3, the 3 pi plus pi, so 4 pi over 3. So sine 4 pi, so this bit sine 4 pi over 3 is minus root 3 over 2. So then if I look at the fourth quadrant, I would get it as 2 pi minus pi over 3, that is 6 pi minus 5 pi over 3. And then 5 pi over 3, and then 2 pi plus pi over 3, that is 6, is it 5? Yeah, so 6 plus 1 is 7 pi over 3. And then I get, once again, so this is 2 pi plus pi, so this is 3 pi. So that's 3 pi minus pi over 3. So 9 minus 1, that is 8 pi over 3. So 8 pi over 3 also lies in the second quadrant, hence it is positive. So I had to do all this to get it. Maybe you already know, you don't need to do so much of extra work that I did. So root 3 over 2. So then I can write, this is like a side work, a rough work I did. We can cancel it, delete it. And that is equal to 1 over 4. We will get 1 over 8 times, that is root 3 over 2, plus now 1/3 sine 6 pi, that is 2 pi, 3 and 2 cancel out, it's 2 pi, so 0, so plus 0 plus 1 over 4 times minus root 3 over 2. So that is equal to 1 over 4 times root 3 over 16 minus root 3 over 8. And that is equal to, if I take root 3 outside the bracket, root 3 over 4. So I get 1 over 16 minus 1 over 8. And that is equal to 1 minus 2 over 16. And that is equal to minus root 3 over 64. And that is the answer. So hence we've completed this question. Hope it's clear. And thank you for watching.